Imagine a tiny spacecraft about the size of a small car, built by human hands and launched into the vast unknown. It carries with it the hopes and dreams of an entire planet, a silent ambassador from Earth, venturing where no one has gone before. Hurtling through the endless dark of space, it travels alone, far from the warmth of the sun, surrounded by nothing but the cold silence of the cosmos. This is Voyager 2, launched in 1977 to explore the outer planets. Its journey began with a thunderous roar, leaving Earth behind to embark on a mission unlike any before it. Its mission: to reveal the secrets of worlds we'd only glimpsed as distant dots in the night sky, to turn those points of light into real places with landscapes, storms, and mysteries of their own. Voyager 2 journeyed past Jupiter and Saturn, sending back stunning images and data that transformed our understanding of these gas giants. It captured swirling storms, intricate rings, and moons we never knew existed. But its most unique destination was Uranus, a pale blue world tilted on its side, never before visited by a spacecraft. This mysterious planet, shrouded in clouds and encircled by faint rings, was a true enigma waiting to be explored. The journey took nearly 9 years and billions of kilometers through the cold, empty vacuum of space. Voyager 2 braved intense radiation, freezing temperatures, and the ever-present threat of micrometeoroids, all while relying on technology from the 1970s. Voyager 2 was a marvel of engineering, built to survive deep space and equipped to study magnetic fields, atmospheres, and more. Its instruments were designed to capture every possible detail, from the faintest radio signals to the composition of alien atmospheres. As it neared Uranus in January 1986, anticipation grew worldwide. Scientists, engineers, and space enthusiasts everywhere waited anxiously, knowing that history was about to be made. This little explorer was more than a machine. It was a symbol of human curiosity and ingenuity, a testament to our desire to reach beyond our own world and seek answers among the stars. The data it would send back promised to reshape our understanding of the ice giants, offering new insights into their atmospheres, magnetic fields, and mysterious moons. But hidden within that data was a secret, a cosmic message that would take nearly 40 years to decode. It was a puzzle that would challenge scientists for decades, hinting at discoveries yet to come. Voyager 2's journey was just the beginning of a much longer story, one that would inspire generations to look up and wonder what else might be waiting in the darkness beyond. The adventure to Uranus was about to reveal more than anyone expected, opening a new chapter in our quest to understand the universe and our place within it. On January 24, 1986, after a journey of nearly a decade across the solar system, Voyager 2 finally arrived at Uranus, the seventh planet from the Sun, and one of the most mysterious worlds in our cosmic neighborhood. The spacecraft swept past the planet, coming within just 81,500 kilometers of its cloud tops, closer than any human-made object had ever ventured before. For the first time in history, we saw Uranus up close. A serene blue-green orb, calm and mysterious, its pastel colors hinting at secrets hidden beneath thick clouds of methane and hydrogen. Uranus's extreme tilt, almost 98 degrees, meant its poles pointed nearly directly at the sun, creating bizarre seasons. 42 years of continuous sunlight, followed by 42 years of darkness at each pole. This unique orientation puzzled scientists and sparked new questions about the planet's formation. Voyager 2's instruments discovered 10 new moons, joining the 5 already known. These moons, named after characters from Shakespeare and Alexander Pope, added to Uranus's growing family of satellites, each with its own story to tell. The probe also revealed 2 faint, previously unseen rings, bringing the total to 11. These delicate bands of dust and ice encircle the planet, forming a subtle halo that had eluded astronomers for centuries. Even more surprising was Uranus's magnetic field. Unlike any other planet, it was wildly tilted and offset from the planet's center, a magnetic mess that defied expectations and hinted at a complex, dynamic interior. Among the moons, Miranda stood out. Voyager 2's close-up images revealed a jumbled, patchwork surface of canyons, cliffs, and ridges, as if the tiny moon had been shattered and reassembled by some ancient cosmic catastrophe. Scientists were fascinated and mystified. What forces could have shaped such chaos on a small, icy world? Was it the result of violent impacts, or perhaps powerful tidal forces from Uranus itself? In just a few hours, Voyager 2 gathered more data about Uranus and its moons than all previous observations combined, transmitting a treasure trove of information back to Earth. The encounter painted Uranus as a dynamic, complex system, an ice giant full of mysteries with swirling clouds, shifting rings, and a family of diverse moons. Yet, hidden in the mountain of data was a strange inconsistency, a puzzle that would baffle scientists for decades, challenging our understanding of how planets and their systems evolve. The true nature of Uranus, with its secrets locked beneath icy clouds and in the orbits of its moons, was still waiting to be uncovered. Voyager 2's historic flyby was only the beginning, a first glimpse into the wonders and enigmas of the ice giant, inspiring generations of scientists to keep searching for answers. As scientists pored over the data sent back by Voyager 2, they stumbled upon something truly odd, something that would puzzle the scientific community for decades to come. The probe detected intense radiation belts encircling Uranus. This was expected, given the planet's powerful magnetic field, but the details didn't quite add up. Normally, such strong radiation belts would mean there's a thick soup of plasma, charged particles, swirling around the planet. But Voyager 2's instruments found almost none. It was like discovering a roaring fire but with no smoke, no heat, and no ashes, just the flames inexplicably burning on their own. To explain this, scientists proposed a leading theory. Uranus's moons must be geologically dead, their icy surfaces acting as cosmic sponges that absorb the plasma, leaving the space around Uranus eerily empty. This idea shaped our understanding for nearly 40 years. The moons were thought to be frozen, silent, and completely inactive, unchanging relics from the solar system's past. Textbooks and scientific papers described Uranus and its moons as a quiet, uneventful system, a place where nothing much ever happened. But science is always evolving and mysteries have a way of resurfacing when you least expect them. What no one realized at the time was that Voyager 2 had arrived at Uranus during a rare and unusual moment, one that would skew our understanding for decades. The data Voyager 2 sent back was just a snapshot, a fleeting glimpse of a cosmic accident, not the planet's normal state. The real story, as it would turn out, was far more exciting and mysterious than anyone had imagined. The mystery of the missing plasma would eventually lead to a stunning revelation, one that would challenge everything we thought we knew about Uranus and its moons. Voyager 2's brief visit had captured a cosmic anomaly, setting the stage for a scientific detective story that would unfold over generations. Decades later, scientists revisited Voyager 2's data with modern tools. In 2024, a team used advanced models to re-examine the measurements. They discovered that just before Voyager 2's arrival, Uranus was struck by a rare, powerful solar storm, a coronal mass ejection. This event happens at Uranus only about once every 25 years. Voyager 2 had arrived at the aftermath of a cosmic upheaval, not a typical day. The strange readings were fingerprints of this solar storm, not Uranus's normal behavior. The hidden message in the data was finally revealed. Context matters. The decades-old mystery was solved by a chance encounter with a solar storm. The real Uranus had been masked by a cosmic coincidence. Science had finally caught up with the truth. How did the solar storm fool Voyager 2? The storm compressed Uranus's magnetosphere, energizing trapped electrons and making radiation belts appear far more intense. At the same time, the storm opened the planet's magnetic bubble, letting plasma escape into space. When Voyager 2 arrived, the radiation was supercharged, but the plasma was gone. The probe recorded a temporary misleading state. Scientists built theories on this snapshot, unaware of the storm's effects. The data wasn't wrong. Our interpretation was. The universe had played a clever trick, only revealed decades later. New technology and fresh analysis finally uncovered the truth. The great contradiction was solved by understanding the storm's impact. This discovery forces us to rethink everything we thought we knew about Uranus. The idea of a naturally plasma-poor system is likely wrong. Under normal conditions, Uranus probably has much more plasma, like other giant planets. The 1986 snapshot showed a planet altered by the sun, not its true self. Our models must now account for dramatic solar effects, even at Uranus's distance. The system is dynamic, not quiet, constantly shaped by solar weather. Scientific papers and textbooks need a rewrite. This is how science works. We revise our theories as new evidence emerges. The implications are profound, especially for Uranus's moons. Our only close-up was taken at a very strange moment. Now, we must question everything we concluded from that single visit. The story of Uranus is far from complete. The next chapter could be even more surprising. The biggest consequence? Uranus's moons might not be dead after all. The old theory required them to be inactive, but the new evidence suggests otherwise. If the plasma was swept away by a solar storm, the moons could be active. Maybe even ocean worlds. Moons like Ariel and Miranda, with signs of geological activity, could hide subsurface oceans. If so, they might vent material into space, creating plasma. Instead of being plasma sponges, the moons could be plasma fountains. This raises the possibility of environments suitable for life. Suddenly, Uranus's moons are compelling targets for exploration. The puzzle of the missing plasma has opened a new, hopeful chapter. The Uranian system could be far more alive than we ever imagined. This revelation shows how much we still have to learn about Uranus. A single flyby can be misleading. We need to return. That's why a new mission to Uranus is now a top priority for NASA. The proposed Uranus orbiter and probe would study the planet and its moons for years, through changing seasons and solar conditions. It could answer questions Voyager 2 raised. Are there subsurface oceans? Are the moons venting material? How does the magnetosphere really work? The 2024 discovery justifies a return journey. There are still major secrets waiting at Uranus. A new mission could inspire a generation, and maybe find another habitable world. The journey to Uranus is only beginning. Voyager 2 continues its journey into interstellar space, leaving a legacy of discovery. Nearly 21 billion kilometers from Earth, its signals take over 19 hours to reach us. Alongside Voyager 1, it's humanity's farthest emissary. The Uranus flyby shows the enduring value of these missions. Decades-old data still yields new insights. As technology advances, we unlock secrets hidden in plain sight. The lesson science is full of surprises, and we must always be ready to question our assumptions. A chance encounter with a solar storm changed our understanding of Uranus and its moons. Now, we see the possibility of active ocean-bearing worlds. Voyager 2's story is about curiosity, humility, and the endless quest for knowledge. Its greatest message: the universe is more dynamic and wonderful than we ever imagined.